Today I'm going to show you something different from what we have been doing so far. So I have here a file called disk.bin. I'm not too sure whether this is a file which is being formatted in NTFS or extended FAT. So what we can do is we can do a sort of a digital forensic analysis to find out what sort of a file type is this. For us to do that, first let's identify and verify the master boot recorder using the MMLS tool. So I'm going to use the tool called MMLS to find out what type of file is this. So to do that, I'm going to first change the location. So on the location you can see that's my location select. So I'm just going to use to desktop, my data labs. So that's where I have it. So here I'm going to use MMLS disk.bin. So you can see, as you can see here, our master boot partition table has got single entry. So here you got a single entry here, and also with the single partition. So you can see we have got one partition which says it could be NTFS or extended FAT, and sector start from sector number 63. So up to first 63 sectors are not allocated, so unallocated. So in this sector we have the partition signature, whether it's the NTFS or EXT or EXFAT. So we have to identify them, but remember these are sectors, these are not bytes. So the only option for us to verify whether this is NTFS or EFX is to go through another tool called Hexdump. But the Hexdump needs to convert the sectors to byte. So we can identify, or we can find out the byte number. So if you see sector 63, every sector is 512 bytes by default. All standard sectors are 512 bytes. Now of course we have ECCs are 4 kilobytes, just to make sure that, because the file sizes has increased and we can't have a smaller sectors, so we have gone the sector sizes to from 512 bytes to 4 kilobyte. Again, so in this I'm going to take the sector size 512, and let's find out then what's the byte number, or what's the starting byte number. So if that's 63, then I have to multiply the 63 by 512 to find out the sector number. So if you multiply the 63 by 512, you will find 32,256, right? So let's go and find out what's in the first sector, which is the sector number 63, or byte level number 32,256. To do that, let's go. I'm going to use the Hexdump tool. So the tool is Hexdump, right? And I'm going to use Hexdump tool to inspect the first 512 bytes. I don't want to inspect everything. I'm just going to inspect the first 520 byte, starting from the sector number 32,256. So if you hit enter, right, this is going to now find out what's inside this sector, right? Let's see what's going to happen. Sorry, I forgot to give the file. The file that I'm going to inspect is this. So now if you look at this, in my first 8 byte, right, so first 3 bytes, just the first 3, so that first 3, ignore it, and then on the next 8 byte I can see it tells me it's an NTFS file type. So I was not too sure whether it was NTFS or extended FAT, but now I can confirm this is a NTFS file. So this is how we use the MMLS and Hexdump tool to confirm a given file is what type of a end partition and what is inside the partition. Now what we can do is we can just input this file to another tool, or DD tool. There's a tool called DD, and we can just put this file into DD tool and then convert just the NTFS, the partition table, the sector size, that length of the sectors, to create a new file. So pretty much in real case in digital forensic, we don't want it to just destroy the original file. So we don't want it to just do anything on the original file, because if you do changes on the original file, this cannot be then accepted, or we cannot present this to a sort of an evidence and basis. So we have to make a copy of this file. To do the copy of this file, what we can use is we can use the tool called DD. So the DD tool is going to help us to convert the file, or sorry, to copy and create a new file. So what we can do is we can use DD. Input file is disk. This is what the file I'm going to input, and your output file is let me transfer the output file to the same directory where I am in. I'm in there. So let me transfer to the same directory, desktop. My data lab, right? And we'll convert, or we'll name it as you can just give a name for this. This is a new dot bin, right? So that's your file type, and I'm going to just ignore the, or I'm going to just consider all the basic sector size to be 512 as the sector size, right? And then you just skip the first 63 bytes, because we don't want the first 63 counts, right? So to skip first we want to skip first 63, right? Definitely it's going to be first 63. So I'm going to first skip 63, and then you have to specify the size, how much size do you want to create as a new copy, right? So you have to specify the size. So the size that I'm going to use it here, you can see this is the size of the sector. I'm going to just copy that. So copy the size, and then I'm going to come back and give count equal paste. So pretty much I've done everything I need to do for these files. I've set a disk input file, and then output file, and the sector size, and I said skip first 63 byte because we are not going to use it, and then I've set this count is total, how much sectors you're going to convert it, and hit enter. So when you hit enter, I'm sorry, there was a wrong command. What I'll do, so the file, let me just do this one again. So we convert this to here we go. So we just converted the file. Now it's just copying the file as a new file here. So you can see it's just creating a new file. So once this is done, let's go and inspect this file again using the Hexdump, right? So we can use the Hexdump command to inspect the file one more time once this is created. So it's creating a new file from this, right? So I'm just creating a new bin file. Let's wait for this to complete. Once it's done, I'm going to just look at the file to confirm that we haven't changed the file types or anything, right? So hold on until I finish this conversion, and then we'll move on from there. All right, you can see that it's still converting the file, but I know the reason it's quite slow, just because I'm transferring it to the same my first disk. But there's another disk I have, which I have created a symbolic link here called external. What I'm going to do is I'm just going to make sure that I transfer the converted file to the external link. That's going to be quite faster. So let me close this one. You can see it's only transferred so much this, and the transfer speed is very slow. So what do I do? Let me transfer this to a new bin under the path desktop external new disk, and hit enter. This is going to be quite faster because this disk has code. This is my secondary disk, and this should, so you can see it's quite fast now. compared to this one. This is only 1.7 gig after all for so much time, but here this is already, it's got a bigger file. 1.4 GB already is there. So this will do the conversion quickly. It will copy the file very quickly. Let's see. We'll have to still wait till this is completed. Normally this takes about 5 to 10 minutes. So you can see it's took almost 6-7 minutes here. I'm going to wait for another 6 or 7 minutes to see whether it will convert the file and create the new file. Okay, hold on until that. Right, you can see here it didn't take that much time. It took only 1 minute to convert the file or to create a new file from the existing bin file, and it converted the whole file quite fastly. So you can see this is the new file that I've just created, 10.7 gig, which is the new file. So what we can do is we can do a hex dump on this new file to confirm whether this is the right file which has not been modified. So let me move to the folder where I am in. So cd dot cd dot, so I'm in the cd external. Right, so I'm going to the command that I'm going to use it again, the hexdump command. But remember, this time you don't really need to go ahead and use every sector or first sector. What we can do is we can just put hexdump minus plus 12i to convert the file. So let me do hexdump. See, the file that I'm going to use here, part, not the this one. Sorry, order. Control C. The command I'm going to use is hexdump. It's new. Right. So let's look at. The reason why I got something different here, I'm not looking at the first 512 bytes. I'm looking at somewhere here 63 or 63rd sector. Now the new file has been ignored. You can see I ignored the first 63 bytes of 63 sectors. So technically I have to look the first sector. So what I need to do is on this command I need to remove the last bits. Right, and hit enter. When you do this, again, sorry, there's a S, so we don't need that S2. So just remove that. Enter. Right, now let's look at the file. You can see here it's an NTFS file, right, the same as the original file we had it here. So look at that. So that's the file we had, NTFS, and the newly copied file is also NTFS file. So pretty much we got a copy of the file. This is for multiple reasons. In digital forensic we don't really want to do anything on the raw file or the new file, so original file. So we always create a copy from the original file to do all your testing and analytics to confirm or to collect the evidence. So we always keep the original file as it is, so we can just present the original file. So this is how we create a copy of the original file using hexdump, DD, and MMLS tools. Hope you enjoyed. We'll go in another video to analyze what's inside this file to do more digital forensic tasks. Thanks for watching. Thank you.